Alright, let's try this again. Last time I didn't get any audio because I didn't set up the audio thing. Um, anyway, this is addressing many of the questions that I've come across throughout a long time about how people are going to fake glass, and I always get backlash for it. And so I want to really make this video out there, or get this video out there, so that people can understand where I'm coming from. Basically, anytime that you render something, or anytime that you make something inside of a piece of visual effects software or whatever, what you're trying to do is trick the eye. You're not really trying to sit up here and make things physically accurate or anything like that. So when people ask the question, well, how exactly do I fake glass to get things to look good, because glass itself really isn't looking all that good. So if we use these physically accurate models, we don't usually get the result that we're expecting to get, or the result that we see in the actual world all the time, even though there are some very good rendering solutions to actually solve the rendering equation. So what we have here is we have this simple scene. You have a couple spheres on the inside, like one of these little highlighted areas is going to be an emission material. And this is a glass material, and this is using a transparency material. So you can see here that the glass is right here. Let's just get this down here really quick. Oh. And we're going along with an analog with Renderman to show you that both renderers are doing the exact same thing. Let's go ahead and show what this looks like. So right now I have a distant light going on, and like I said, this is a glass material and this is a transparency material. Now there's a couple things that I really want you to take a look at. One of these sides has light transmitting through the glass, or what's supposed to be the glass, and light not transmitting through the glass, except for the internal portion here. Now this is a pretty intense light. If you look at the values here, it's fairly intense, and but it's not making a way through here at all. The other thing that I really wanted you to take a look at is the fact that this area here is not resulting as many samples as this side here. Now the reason for that, and even if we were to take the glass and we were to drop the index of refraction down to 1, basically what you see is the sphere disappearing. And you do see like a little bit of extra light coming in from the outside, because you're reducing that index of refraction, and so the bounces are more linear. But the thing is that even if you put in an index of refraction of 1, you can still see that it takes a long time to solve. There's more noise there. And the reason behind that is basically the glass material that we have assigned to that is still calculating the interfaces as a bounce. So from the air to the surface of this is one bounce, and from the inner surface of this into the inside here is another bounce. And then how many other bounces are bouncing around in here until it finds this light source? Well, you can exhaust it. And so even if we were to leave this maximum bounces up to 12, the transparency bounces are actually separate from the bounces overall, which kind of define these lines here. So I can show you that really quick. If we go down to 4, there isn't enough bounces on the transparency here. But there's still light coming through here. And if we go down to 4 here, then there isn't as many bounces over here. And so the transmission is really driving some of this. Right? And that doesn't help at all. So I like to keep these bounces really low because I like to have things calculate. So if I were to get the transparency up to 6, that would be enough to see what I needed to see here. And again, we're taking a look at this as being one of these layer weight types of things. Fresnel doesn't really work, but as well as I'd like it to on this. So the layer weight is basically matched to see the reflections here by eyeballing, and this value here works pretty good for me and for this scene. But remember, this layer weight is just defining the glossy reflections. The transparency is telling it that this is transparent. So don't worry about calculating the interfaces. I don't care about the bounce here, and I don't care about the bounce on the other side. Just blow right through it. And so if we had a transparent shader without any of that stuff, we're kind of looking at this little rim here, but we don't have anything really defining what it could actually be. Remember, we're just trying to fake things here, right? We've totally lost our reflections in some areas. And so if we put this back in here, we get our reflections back full force. And it kind of defines that just a little bit better, doesn't it? Also, like I said, the sample's out here. Let's turn off the lights. If we turn off the lights and we let this go for a little bit, I'm not quite so sure if we could let this go up to 512 plus samples that it would ever reach the quality that this is going to reach in 128 samples. Because it's not really calculating those interfaces, like I said. Already the floor is several times better than this. Why would you ever want to deal with this type of situation if you're dealing with a thin glass situation such as this? You wouldn't. I mean, it doesn't happen in the real world the way that I showed this way. So why would you let it happen in here? So we can go ahead and turn off this emission really quick. Nope. Let's see what's going on there. Let's see if we have the world. We have the world in there. So here's the world lighting situation. Okay. And so you can see that some of the reflections in here are comparable, right? I mean, my background's it's looking at the world from a different point of view, but it's believable, right? I mean, if it's believable, why not use it? If it's believable, cheaper to calculate, and it tricks your eye, why not use it? Why argue the point? Why even argue the point of like whether or not, oh, glass is just glass? No, glass isn't just glass. It isn't. It will never be. So take a look at some of the stuff in Renderman forums and some of their documentation, and it'll say that, you know, in many cases you don't need certain shading techniques in certain situations, and this is one of those situations where you're probably going to use a thin glass material over anything else. So just to show you that Renderman has the same problems with it. This is a thin glass material, and this is a traditional glass material, and you can see that they're the same types of things. The one thing that Renderman has the advantage of is still being able to use the index of refraction, but it cuts down some of the calculation on this stuff as being like thick. It's kind of like what LuxRender would call architectural glass, and usually if you use architectural glass in LuxRender, most of the light just blows right through it. You know, there isn't any of these extra calculations and bounces and stuff like that you had to have in actual glass, but you still have the index of refraction here. And so as you can see, it's the same types of results. We're not even getting rays out of here. Okay, and even though this is a preview render, it should show the rays out of here, but there aren't enough bounces, there's not enough anything to get the light out of here. All it can see is that, oh, well, there's this bright spot right here. But none of these indirect bounces are coming in here to calculate any of that stuff, so I need more indirect bounces to actually show that. But with this, you can already see that it's escaping, or that other bounces are able to make it through here using the same amount of calculations. So if I'm going to use the same amount of calculations, I bet you that I could render this a lot faster if both of these were the same material, or at least get exactly the same results on both sides, obviously. So if this is the method that you're looking for because you want sunlight that's shining through a window and to actually hit the ground somewhere instead of just disappear and not be there, then use this method. Again, you're tricking the eye. But in this case, tricking the eye and not looking at this as an actual um, type of thick or glass type of material, but you're using it as the thin glass type of material that's been defined here, and it is thin. You can get the results that you're looking for in almost all situations dealing with architectural type of visualization. There's absolutely no reason why you would ever need to slap an actual glass material on a piece of glass, in your scene, especially if you want good lighting situations. And so, um, why go about it that way at all when you could go about it this way and just use what's available. Look, I mean, even the environment lighting gets through there. Okay, so to show you exactly what I'm talking about, if I can go back here, we're going to take a look at this scene, and it's slow to trace because I have a lot of bounces in there to try to get into nooks and crannies and stuff like that. But as you can see, I have a sky texture out there, but I also have a distant light to shine on the wall. Okay, so I'm using this actual transparency method here to get through the, let's just ignore this crap over here because that was Radeon Pro Render stuff. It was. Okay. So if I were to use the glass method, and this is what I was having problems with before, now I'm defining it as glass. What happened to the sun? I mean, you can still see it here because there aren't glass materials there. There are gaps in the mesh or whatever in the walkway that allow the sunlight to get in, and you can see little parts of it here. That's because the light rays or the camera rays are actually able to go out there, find that stuff, bounce off, and eventually find its way outside. But it can't find its way outside if it has too many bounces to get outside, and it can't find that sunlight too well if you have too much refraction, I suppose. So you just replace it with the transparency, and if there's ever a chance where you're going through there where it could pick up a reflection of some sort, you want to have your reflections in your scene, there you go. That's your reflection. This is determining the angle, and then this is just saying, it's transparent. Just blow through that material. And then you get this. And so it also it contributes a lot more light to the scene because it can find it. And I do believe I did have portals on there. But I don't think I have any there now. I might. Yeah, I do. So I do have some portals on there to direct it, but either way, that's a night and day difference. So trick the eye, get the light that you want to get. If you have internal light sources that are behind glass, use this method. If you want light sources that are outside the glass, use your portals and use this method. For anything else, like if you're using glass cups or some sort of hero thing that's in front of everything, use the glass material. But other than that, anything used in this type of distant situation, or even maybe even possibly in these situations, that might be overkill to use glass. I mean, let's see here. I have glass and a volume. Yeah, and I think I did this. See how that clears that up right away? And I don't need as many bounces. And then I was experimenting with the volume absorption type of thing to get the tint of the glass on the edge. Still haven't been able to do much of that, but I still have reflectivity off of this surface here. I have, there's going to be some sort of specular component off of here, but look at how well that just goes right through there. You wouldn't expect to go into the museum and go, well, look at how tinted the glass is around there. The museum wants this to keep you away, but not to tint everything, and you absolutely lose most of the rays or the samples through this portion when it has to go through 2 layers of this stuff. And definitely when it goes through 1, 2, 3, 4 layers of that stuff, you're going to lose transmission through there. So you can use this as well, right? I mean, why not? You're still getting your reflection. You're still getting everything that you want to get. It's that it takes less time to actually calculate, and it gives you a thin glass type of look. But it's up to you, you know, whatever. I'm just throwing that out there for you to use whenever you want, and hopefully you understand how you can get light and things to transmit through certain types of materials that you want people to believe are glass without using a glass material. And that's it. Okay, so if you have any other questions or whatever like that, you like this thing, you don't like this thing, whatever, leave comments, thumbs up, thumbs down. Um, I usually don't look at any of that stuff, but this is just out there offered for you to hopefully help you out in some of your rendering.